Assalamualaikum, my name is THABRANI bin Muhammad FAUZI, and today me and my team will be presenting our 506 mini project titled Water Level Classification. Alright, let's begin. Before we start, I'm going to introduce you to my team member. We start with Muhammad AZRI bin Muhammad ZAKARIA, AZIM Ali bin AFTAR Ali, Ajwad bin Muhammad Akram, and myself, THABRANI bin Muhammad FAUZI. Alright, we start with the introduction of the project. So, the goal of this machine learning project is to develop a model that can accurately classify image of a water bottle level. This model will be trained on a dataset include a diverse set of water bottle images representing different size of water level. One fact about the bottle level classification is we use a convolutional neural network, which is CNN, and that are particularly well suited for this task because of the ability of identify the exact feature of an image. So in this case of water bottle classification, a CNN can be trained to identify the different level of water in an image by analyzing the feature of the image, such as the amount of water and the shape of the bottle. Alright, next is the problem statement. So, manual monitoring is required, which is time consuming and prone to errors. This is because manually checking the water level in multiple bottles, especially in a large quantity, can be tedious task that require a significant amount of time and effort. So, human errors can also lead to inaccuracy in the classification, such as misjudging the level of water in a bottle or confusing one bottle for another. So, a system that can automatically and accurately classify the level of water in a water bottle based on the image of the bottle would greatly improve the efficiency and accuracy of the monitoring water consumption and inventory management. Next, I pass the slide to another presenter.
Thank you, Atta. And now we are on to objective. This project aims to accurately determine water bottle levels classification. The objectives of this project are as follows, which is 1. To develop a machine learning model that can accurately classify water bottle images based on their water levels. And the second one is, the goal is to develop a model that can accurately classify a given water bottle images based on its water level. This is the data analysis. The dataset consists of images of water bottles that have been categorized according to the amount of water they contain. Full water level, half water level, and overflowing are the three image categories. Half water level contains 139 sets. Full water level contains of 303 sets, and overflowing contains of 39 sets. The dataset will be used to build and test a machine learning model for classifying images. Each image will be labeled as either full water level, half water level, or overflowing throughout the model's training on the provided images. These images are in .png and JPEG file formats and are RGB images with 3 channels.
Thank you, Azri. Now for the CNN architecture. CNN, or Convolutional Neural Network, is a type of neural network architecture that is specifically designed to process and analyze visual data, such as images or video. The architecture of CNN typically include multiple layers, including convolutional layer, pooling layer, and fully connected layer. And this is our CNN architecture. Okay, so this is the coding and the model. So, the first layer is a convolutional layer with 32 filters. This layer does not have any neurons, but it extracts 32 features mapped from the input image. The second layer is a max pooling layer. This layer also does not have any neuron. The third layer is a convolutional layer with 32 filters. This layer also extracts 32 features from the map, the input feature maps. The first layer is another map spooling layer. The fifth layer is a convolutional layer with 64 filters. This layer extracts 64 feature map from the input features map. The sixth layer is another map spooling layer. The seventh layer is a flatter layer. This layer is used to flatten the output from the previous layer into a one-dimensional array of 18,496 neurons. The eighth layer is a dense layer with 512 neurons. This layer is connected to all 18,496 neurons in the flatter layer. And the last dense layer is connected to 512 neurons in the previous layer, and it has 3 neurons. So this model, the last dense layer has 3 neurons. So this is our coding for the training model. So as you can see, we use class optimizer AZIM with learning rate 1 exponent negative 4, and it will generate 50 epoch. So this scatter plot graph has been generated after 50 epoch. So the last accuracy is 76.75%, which is quite high. Next, the experiment. So this is our experiment table. We have run 7 different experiments using different optimizer, number of epoch, and the range for pre-process. But unfortunately, the higher accuracy is for our first experiment, which is 76.75%.
Thank you, Mr. Ajwad, for the very good explanation. So the result of the experiment is that it has sync with three most important thing, which is response time, memory usage, and number of epoch. And for the response time, we wrote the script in Python to train and test the dataset. The accuracy of the dataset is 60.7% at the starting point before further training and optimization. The final classification rate of the water level is 76.74, which shows an increase of accuracy at the end of the training. So for the result in the memory usage, the data is saved automatically to disk from the notebook and can be reused again. All the images are real and original loaded from the dataset file. The train folder would save about 66.1 MB of the memory usage, 76.74. And the result in the number of epoch is that the network reached 76.74% accuracy in less than 51 epoch. Every analysis and every experiment will surely have its advantage and also drawback. So for our experiment, the advantage is that this project, that the water level classification using machine learning may be effective in terms of resource management in the production industries. It is because CNN can be used to monitor and optimize the the water level resource in industrial process, reducing waste and increasing efficiency. But there is also drawbacks of this experiment, which is CNN may have a limited generalizability, meaning they may not perform well on new or unseen data. With a difference in lighting or water turbidity, it is possible to negatively impact their performance. Subsequently, the cost could be high. Implementing and maintaining a water level classification can be expensive because of the items, and so on, especially in large production facilities.
In conclusion, CNNs are a powerful tool for water level classification due to their ability to extract features from images and make correct predictions. The above code demonstrates how to implement a CNN using the Keras library and pre-process the data using image data generators. The model includes several layers such as the convolutional layers, max pooling layers, and dense layers, with activation functions like ReLU and softmax that are used to introduce non-linearity in the model. The model is then trained using a train generator for a specified number of iterations or epochs. using an optimizer and a specified learning rate. The CNN model is able to learn from the data and make accurate predictions on unseen data. This approach can be used to classify water level in other scenarios as well. Okay, that's all from us. Thank you for watching.